Warning: lithium is a very reactive metal. Lithium batteries may ignite or explode when improperly disassembled. Fire safety protocols must be in place. Hi guys, here is MIH. Lithium batteries, beside being known for their tremendous usefulness, is also known within the amateur chemistry community as an easy way to get lithium metal. In this video, I'll extract the lithium metal from a button battery, as well as determine if this way of getting lithium is cheaper than buying the metal directly. Skip to the end if you want to know the conclusion, but stay with me if you want a crash course on batteries. Now, before I start, I must emphasize that only single-use lithium batteries contain lithium metal. Rechargeable lithium-ion batteries only contain lithium in its ionic state and are not the main topic of today's video. There are two main types of single-use lithium batteries: cylindrical batteries and button batteries. The most common cylindrical type by far is Energizer, and many YouTubers have demonstrated the extraction of lithium metal from it. But in my area, cylindrical batteries were much more expensive than button batteries, so I bought a bunch of button batteries to see if I can get the lithium for cheaper. The particular one here is CR2477. Now, a side note about how button batteries are named. The letter C stands for the chemicals used in the battery, in this case, lithium metal for the negative and manganese dioxide for the positive. R means that the battery has a round shape. 24 stands for the battery's diameter, 24 millimeters, and as you probably have guessed by now, 77 stands for the battery's thickness, 7.7 millimeters. CR2477 is among the largest button batteries around, so it presents the greatest value by having more lithium per battery. Smaller button batteries like CR2450 and CR2032 also work if you have trouble finding 2477, but remember to select the CR type and not other types that don't contain lithium metal. Before opening the battery, we also need to know its structure. This isn't only about figuring how to open it, but also a major safety precaution, since if you know about the battery structure, you can avoid risks of fire and explosions and deal with them properly if they actually happen. Lithium button batteries consist of an anode case, a cathode case, the anode and cathode chemicals, an insulating gasket, and a separator. The two cases serve to hold the chemicals in place, the gasket acts to prevent shortcut of the anode and the cathode, and the paper separator is soaked in electrolyte to allow ions to pass. Note that the edge of the cathode case is folded inwards, which tightly holds the anode case and the gasket in place. Therefore, our first step is to bend this edge outwards and reveal the gasket. To do this, the best way I found was using a wire cutter to hold down the edge and twist it outwards using your other hand. Remember to wear insulating gloves when doing this, and only touch the outer cathode case and not the inside anode case, or the battery will short out. After applying some force, the casing should be twisted to the side, and the black gasket should be seen. The next thing to do is move the wire cutter along the edge, and repeat until the entire gasket is revealed. Remember to use the opening that you previously made to help you along. After all of the edge is twisted, the anode case could be simply lifted using a screwdriver. As you can see, the cathode case is filled with a black substance, which is manganese dioxide. The paper diaphragm is removed using the screwdriver, and the lithium metal is revealed beneath the anode case. If you're really fast while performing these last steps, you might see some really shiny lithium, but my hands are quite slow, so the lithium already tarnished. As you can see, lithium metal is really soft and is easily pushed around by a screwdriver. Now the battery is successfully opened. I need to know how much lithium is in it. To do this, I decided to throw it in water and measure the volume of the hydrogen gas produced. However, I don't have a graduated cylinder to do this, so I came up with an alternate method. I measured the volume of a reagent bottle by filling it up with water and weighing the water. I filled it up again and stood it upside down in a basin of water while trying not to let any air in. Now I can partially fill the bottle with hydrogen and measure the amount of the remaining water to determine the volume of the hydrogen. I then threw the lithium into a conical flask containing water and quickly sealed it. Bubbles of gas are quickly released into the bottle as the lithium reacts vigorously with water. After no more gas is released, the bottle was sealed under the water and taken out of the basin. The mass of the water in the bottle was measured to be 113 grams. Since I've measured the volume of the bottle to be 675 milliliters, we have collected 562 milliliters of hydrogen. Based on this number, the amount of lithium in the battery can be easily calculated. I won't bore you with the details, but we get two important numbers as our conclusion. First, the price of lithium metal using this method is 3.74 RMB per gram, which is around half a dollar. Of course, the price of the battery itself should be more expensive in your area because I bought 20 of them for like $3.3, but honestly this number really surprised me. The other number was quite interesting as well. The battery actually has a capacity of 1210 milliamps hour, but it was only labeled as 1000 milliamps hour. Again, this is probably because I bought relatively fresh batteries out of the factory instead of batteries that have been sitting around for a few years. But overall, I would say that getting lithium from bottom batteries is definitely a bargain, and a great tool for amateur chemists. Hope this video helps, and see you soon.